Recall that the reciprocal of a number is where we take the numerator and the denominator and we flip them. So the reciprocal of a non-zero real number a is going to be 1 over a. And then we can also say the reciprocal of 1 over a is a. Now recall, when the number is multiplied by its reciprocal, the product is always going to equal 1. So for example, if we take 4 over 5, and I times it by 5 over 4, I'm going to get 20 over 20, which equals 1. So similarly, for a function f of x, its reciprocal is then going to be 1 divided by f of x, provided that f of x, the denominator, cannot equal 0. So therefore, given a function y equals f of x, its reciprocal function is y equals 1 over f of x. So let's take a look at the base reciprocal function and see what it looks like. So I have this very large table of values here, which I'm going to fill with some numbers into f of x equals to x. And then what I'm going to do is I'm going to take the reciprocal of the y values and write that as 1 over f of x, or it equals 1 over x. So I'm going to start with some small numbers. So let's go -8, -7, and we're just going to increase all the way to 8. Okay, and then I'm going to take these x values, and then I'm going to substitute it into my f of x equal to x. So that, for example, when I plug in -8 in for x, my f of x value is also -8. So then I'm going to fill in my second column. So when I plug in -7, I get -7, -6, I get -6, and so on. All right, so I have my first and my second column of numbers filled in, and nothing really interesting. They are identical, and let's just graph this on our graph to the right here. So we have -8, -8, -7, -7, and so on. So we're going to have this straight line that goes right through here. So I'm actually going to just freehand draw this through. You should probably use a ruler. Okay. So now let's figure out what happens in our third column. So our third column is where we have the numbers 1 over f of x. So that means all of my numbers in my second column are going to be written as 1 over that number, taking the reciprocal. So I have 1 over -8, 1 over -7. Now remember, having 1 over -8, that's actually the same as saying -1/8 and -1/7, and so on. So I'm going to write the rest of the numbers, and I'm going to pause now. All right, so now I've also filled in my third column, except for 0. So when I take the reciprocal of 0, I'm going to get 1 over 0. However, remember, we cannot divide by 0, so instead of writing error or no solution, we say that this is undefined. So I'm going to write undefined here. All right. So some important things to note. Notice that -1 stayed the same, and so did 1. That also stayed the same. All right, so let's graph these points, and what we're going to do is we're going to use the first values where x is, and we're going to use our 1 over f of x to graph our y value. So our first point is going to be -8 and -1/8. So really tiny, very close to the x-axis, and then -1/7, and so on. Okay. So this is a little bit hard to graph because they are really small. So I'm going to jump to -2 and -1/2. So -2 and -1/2 is right here. Oops. And then -1 and -1, we get the same value. Notice that down here we have 0, and it says undefined. So to graph something that's undefined, we use a dotted line going straight down. So it looks like this. Okay, oops. And this line has a special name, and it is called an asymptote. All right, so let's continue plotting the other points. So we have 1 and 1, and 2 and 1/2, and so on. All right, so the other ones are not really necessary to plot, so I'm going to just stop. I'm going to connect my points. I want to connect my points. Oh, I erased my line. Let me put that back here. Sorry. I want to erase this line and connect that a little bit better. So it will get closer and closer to the x-axis, but it will never touch, because if you look at the table of values, it is 1 over 7, 1 over 8, and then eventually we'll get 1 over 9 and 1 over 10 and so on. But it will never actually approach 0. Sorry, it won't get to 0, but it approaches 0. So that's why I'm drawing this arrow to show that. And the same thing will happen on the left side. So I'm going to draw this. Okay. Now, what happens in between here, between 0 and 1? So let's say we picked a number, which I didn't put into my table, but let's say I picked a number half. So let's put in half right here. If I put in half, this should say negative a half. My f of x value is also negative a half. But when I take the reciprocal of that, that's going to be negative 2. Okay, let's pick a number on the other side. So let's say I take a positive a half. Then my f of x value will be a positive a half. But my reciprocal will then be 2. So graphing these two new points, I have negative a half and negative 2. So negative a half and negative 2 is right here. And then I also have a half for x, and y is 2. So half and 2. So if I pick more and more points, I will see that my graph looks like this. So I kind of have two L shapes. Okay, one, they're in opposite quadrants. They approach these asymptotes. Let me draw this a little bit better. But they never touch. So they don't touch the vertical asymptote. And it also doesn't touch the horizontal asymptote. So there's also a horizontal asymptote right here. All right, using my base graphs, let's summarize the information in a chart, which is located on the next page. So, looking at the graph, we can see the domain of y equals x is equal to all the real numbers. So x is such that x is all real numbers. So this is just the fancy way to show that. And same with the y's. The y's are also all real numbers because it's a straight line. However, when we take a look at the reciprocal, the domain is all real numbers. However, there is kind of a cutoff right here at at x equals to 0. And also for the range, there's also a cutoff here where y equals 0. So how we write that is we say that there is an x value such that x cannot equal 0. And then comma, we can write that it is all the real numbers. So this is a very formal notation. Same thing, y such that, so the vertical line means such that y cannot equal 0, but y is a real number. Now imagining the line, as x becomes a very large negative value, y also becomes a very large negative value. So whatever x does, y also does. And then as x becomes a very large positive value, y also becomes a very large positive value. Now, if you take a look at the reciprocal, as x becomes very, very large, it actually, y approaches 0, and we say it's from below. As x becomes, oh, sorry, I was pointing at the wrong side. So as x becomes a very large negative number, pointing to the left, sorry, y approaches 0, and then we say it's from below because it's approaching the asymptote from below. Now, as x becomes a very large positive number, going to the right, y approaches 0 because it's getting closer and closer to 0, but it's coming from the top or from above. So let's write that down. So as x becomes a very large negative value, y approaches 0 from below. as x becomes a very large positive value, y approaches 0 from above. So because of this, we get a horizontal asymptote at y equals to 0. And you'll actually learn more about this even more so when you take calculus. All right, the behavior at x equals 0. So when x is 0, we have y equals 0. However, we notice with the reciprocal, when x is 0, the y value is undefined. So therefore, we get a vertical asymptote this time at x equals to 0. All right, now this is really important and very useful to graph. You will notice that there are some points that stay the same on both graphs. And remember, those are called invariant points. So if you compare the blue line and the reciprocal graph, I can see that at these 2 points here, at -1, -1, and 1, 1, they are the same value. So this occurs for both because that's why it's an invariant point. So we can say that the invariant points are at -1, -1, and 1, 1 for both, because it's essentially comparing the two graphs. So what I recommend that you do when you want to draw the graph of a reciprocal function is to follow these steps here. So I like to always draw the original graph first. So draw the original graph, okay? And then what you're going to do is do some, I guess we can call them transformations. So what happens is the x-intercepts, because they're going to become reciprocated, and if it's 0, if x is 0, then they're going to become vertical asymptotes. So all the x-intercepts become vertical asymptotes. And then the x-axis, at least for now, will become a horizontal asymptote. Now that changes later on when you get to higher levels of math, because we can move that asymptote around. We're going to replot the invariant points, and that occurs when y equals -1 and when y equals 1. Okay, so these are invariant points. They don't change from the original graph and then to the reciprocal graph. The 1 and the -1 for y's stay the same. And then finally, you're going to take the reciprocal of several y values. So the x will stay the same, and then you're going to plot these new y values moving up and down. So if f of x is positive, remember that the reciprocal is still going to be positive. Okay, it doesn't change signs. If f of x is negative, then 1 over f of x is still going to be negative. Again, it does not change signs. Now, if the y value, the f of x, becomes very large, if y becomes bigger and bigger and bigger, 1 over y then has to approach 0. It's going to get smaller and smaller. And oppositely, if f of x approaches 0, so now y is getting closer and closer to 0 on the original graph, right? Then the reciprocal, 1 over f of x, will then become very large. Okay, so those are the steps that you can use to draw the graph of any reciprocal function, not just a line, but we will focus on lines for now.